Welcome back to the Water Table. Today we're joined by Chris Hay. Chris is a researcher slash just overall water industry expert, kind of across the board. Has a lot of different experience in drainage water management as well as some stuff on the irrigation side. So a lot of crossover with agriculture and water and a bunch of different environments. So Chris, welcome onto the Water Table and thanks for coming on.
Oh, you're welcome. Yeah, it's always a pleasure to be able to talk about ag water management. So thanks for having me on.
Yeah, for sure. And that's kind of one of our goals here with the Water Table is promote promote the education and some of the information as much as we can and bring on guests like yourself of experts in the industry and kind of talk through what's been going on in the industry and kind of where we're heading. And that's maybe some stuff to jump into. Want to give a little bit of background on yourself and you got your bachelor's and master's from Colorado State University, correct?
That's correct. Yeah. Go Rams.
In what was your major and focus there?
It was ag engineering. So they had a little bit of a unique department. It was combined with chemical engineering. So the first degree was officially just ag engineering. The second one was bioresource engineering, but still basically ag engineering. Gotcha.
And then you moved on to get your PhD at Nebraska Lincoln, right?
That's correct.
What were you researching there?
A little bit of a funny story. I went there thinking I was going to do groundwater surface water interaction because I'd come from Colorado where that was a huge issue and I knew it was coming to Nebraska as well. And so I thought I'd be there kind of at the right time to do that. Well, I was a little ahead of the funding, and so no one was ready to quite fund that work yet. And so I kind of scrambled around, and I ended up working on the Missouri River and really looking at fish and invertebrate numbers and relative to the Missouri River hydrology. So some of the fisheries folks there had collected this large data set, and they were really looking for a hydrologist that could compare that to what they were seeing with hydrology and how the river was operated. So a little bit of a tangent, a little bit aside from what I had been doing and what I'm doing now, but it was interesting. I say one of the things I came away with, I came away tri-lingual. I could already speak engineering, but then I had to learn to speak statistics and I had to learn to speak ecology too. So.
Oh, that's great. Good, good background there. That's usually not what people think on trilingual, but hey, all useful there. Want to touch on, you said the interaction of groundwater and surface water, and we've gotten this question a handful of times, just kind of randomly talking. As it relates to ag water management, what is that relationship? When you're thinking about tile or thinking about sub-irrigation or maybe just irrigation and stuff too, we get that question, how does that affect the aquifer versus what we're doing more near the surface?
Sure, and yeah, I think the main answer is we really don't have a great answer right now.
That research never got funded, huh?
Right. There's some things we think we know that where we're doing ag drainage is where we've got poorly drained soils anyway, and that's because we've got a restrictive layer that's preventing good drainage to begin with, and so we're really not getting much in the way of groundwater recharge in those areas, that prime recharge tends to happen, in recharge areas where there is, some connection more between those surface soils down to groundwater, and so that's really where most of the recharge happens. And so, yes, it probably has a minor impact on maybe some groundwater recharge, but it's going to be pretty minimal just because there's not much water that can make it through that restrictive layer, which is, again, why we're doing drainage in the first place.
Right. Yep. And maybe just to dive into some of that a little bit more, and, that's the one of the principles, I guess, with drainage is you need to have that bottom to that perched water table. Otherwise, if water just keeps moving downward, then there's no need to have any other subsurface drainage in there too.
Exactly. Yeah.
You mentioned those recharge areas. Is there examples that, is it like limestone areas or what? Do you have any examples of what those are?
Sure. In karst areas, it would be those limestone areas. But in general, it's just going to be anywhere where there's a discontinuity in that restrictive layer, and so then you've got a chance for that groundwater to or that infiltration to move down to groundwater. So oftentimes it's going to be kind of in the upslope areas, but it doesn't necessarily have to be. But anywhere again where you kind of got a discontinuity where you've got that opportunity for water to move down.
Gotcha. Yeah, that's I've always been curious on that. So they bring on a hydrologist and get to learn a little more too. Cool. Yeah. So after your PhD at Lincoln, there's just a whole bunch of different aspects that you get into with different academia and consulting, some government work, NGOs in the industry. Kind of where'd you go from there?
Yeah. So once I finished my PhD, I did a little bit of work still at University of Nebraska, where I was looking at evapotranspiration, so figuring out crop water use, and really related to irrigation. Then went up to South Dakota State. And thought I was going to be doing irrigation up there as well. That's what was written in the job description. But I got up there just as things had gotten really wet, and so no one was calling me about irrigation. And the few that did said, "Oh, I was doing a good job because they hadn't turned their pivots on." But everyone started asking about drainage, and I was like, "Well, drainage? I hadn't done anything with drainage since a class in my master's degree 15 years prior." And so I kind of scrambled around, and fortunately Matt Helmers was a classmate of mine at Nebraska, and so I knew Matt really well, and so I called Matt and said, "Matt, you got to help me out. I got to figure out drainage." And so he got me in touch with the right people, and once I got in touch with him and Gary Sands and a lot of the other academic folks that were working on drainage in the Midwest, it was a good group to work with, and I got up to speed fairly quickly. So figured out drainage in South Dakota and did a lot of work on there was a lot of concerns about both what it meant for downstream flooding and downstream water quantity, and then also the water quality issues. And so both working with farmers on what they needed for drainage and how to get the best investments out of the drainage that they were putting in, and then working with the public on understanding what it meant for water quantity and water quality. So a lot of education around that, which was really critical at that time.
Yeah, and still is.
Yes,
it
yes.
still is quite a bit. And still looking at the same stuff, I'm sure, and developing those relationships and kind of open up those conversations with the same folks, the same entities too. So
yeah. But kind of realized that as much as I enjoyed what I was doing, I was kind of ready for a change, and wanted to get a little closer to the ground than being in the ivory tower. So came to Iowa where it seemed like all the action was around drainage and water quality, and got on with the Iowa Soybean Association and their conservation team that has done a lot of good work related to drainage and water quality, and especially edge of field practices. And so it was a chance to do a lot of what I really enjoyed about academia, but without some of the headaches and hassles of being an academic too. So.
Sure, for sure. Was it about that time too where transforming drainage kind of picked up and kicked off?
Yeah, I actually, got started with that while I was still at South Dakota State, but then was able to bring that with me to Iowa Soybean. And so I think it was kind of a nice partnership then that, I had access to farmers and what farmers were thinking, and could kind of contribute that back to the project. And so I think it was a good collaboration, and then good for me to stay connected then with the folks doing the actual research too.
Sure. And we don't talk about it a whole lot on here. But we have all the guests, and we were definitely running in those circles too. But can you give a kind of a high level overview of what that transforming drainage project was all about?
Yeah. So the funding call was really related to more water quantity than it was water quality, and so it was a chance for us to kind of a lot of the funding prior to that had all been water quality related. So this was a chance to think a little bit about some of these water quantity questions then too. So really what we were looking at was what was the impact of more storage in the landscape in these drained areas. And so, whether that was, storage of water in the field with controlled drainage or maybe, some short-term storage in buffer areas with saturated buffers. And then kind of the new kid on the block was then drainage water recycling. And so, what if we actually created storage and captured and stored that drainage water and then put it back to use as supplemental irrigation. So it was really kind of focused around those three practices, really, again, tied to trying to enhance storage in drained landscapes.
Mm-hmm. Awesome. Yeah. And actually that was, I think back when I was in college, I got part of that funding for our senior design project, got looped into that. And I think that's probably where we first started crossing paths there, and eventually took my career where it's at now. So it's been a fun ride, and kind of a lot of cool ties back to back to all these same folks and a lot of this research that's been going on with a lot of the same practices, but kind of continues to develop and grow over time. And was just talking with Keegan Colt on recording a different episode too of trying to scale out a lot of what we learned through transforming drainage and now kind of what's called the conservation drainage network, building out those networks. Not only what does water quality and quantity issues look like here, but we also went to Chesapeake Bay area and looked at that, and we were in I think Ohio for the last CDN for some of that stuff. So overall, just water management looks differently in different areas and different markets under different operations too, and different topographies and everything. So that's been a really cool growth or area that I've got to see myself growing in different aspects too. But thanks a lot to a lot of you folks that kind of kicked off that project and started looking into answering these questions that have been around for a while.
Right.
Yeah, cool. And then so working with Iowa soybean for a while. Now you're working out doing your own consulting work currently, right?
That's right. Yeah. So chance to have a little more freedom and not be tied specifically to Iowa. So doing some work now with Indiana, but continue to do some work with Iowa soybean and others. But still, really all around ag water management. Still really active on still doing some drainage water recycling work, which I think is, there's a lot of interest in here in Iowa, but growing around the Midwest as well, all things ag water management and water quality still.
Yeah, absolutely. Yeah, just how you're suited. Perfect. Walking right into that. So talked a little bit about drainage water recycling. We bring that up a handful of times, just kind of holding on to more water, being able to use that for irrigation later on. But what are some of the questions that you're starting to dig into and starting to answer with the work that you're looking at?
Well, we started with really the impetus behind it was this opportunity for a win-win. So, helping farmers get some impact from these edge of field practices where now they've got that supplemental irrigation where they can actually see a crop yield benefit. Chances for some modest benefit with controlled drainage, but this one's where you can really start to see some big impact from having that supplemental irrigation for water short periods, and then having the drainage there for when you've got too much water. And so, there's a chance to have something where we can really show a strong benefit back to the farmer, but then also have that public, water quality benefit at the same time. So that was the idea behind it. And so, kind of the first research was, well, is that what we actually see? And so, we were fortunate to have a farmer that put in a system here in Iowa, back in 2015, and so they'd started irrigating as early as 2016, and so we had a data set of their yield, so we could look at what the yield impacts of that were over time, and we could see that average about 35 bushels per acre, but 1 year where they basically doubled their corn production. So we could start to see those benefits, and then we wanted to see, well, do we see the water quality benefits that we think we'll see as well? And so you've got a couple other sites now that we're monitoring as well. And so with 3 sites, we've been able to monitor what's coming in and what's going out and track those changes in water quality and see positive benefits there too. So that's really where the start was. And now where we're going is some of the next questions about what are the economics? Does this pay for the farmer to make that irrigation investment? What's the public benefit then from water quality? And so that's some work I'm working on with ISG and EDF then is to dig a little deeper into the economics and try and help make that case then.
Yeah. And maybe dive into that a little bit more, and it might be some stupid questions on it, or simple questions at least. So you mentioned about on average 35 bushel an acre increase. I assume that's mostly on corn yield for
right.
Essentially looking at before and after, or I guess benefit of drainage water recycling, right?
Yeah. So this field near Story City where we've got this longer term record sets us up really nicely that they've got part of the field that is irrigated, so about 60 acres that's irrigated, and then another 100 acres that's part of the same field, so same soil, same management that's not irrigated. And so we've got a nice controlled treatment where we can actually see pretty directly what the increase is from that supplemental irrigation. And so But at this point, pretty much all corn. We just got our first soybean years, and so we did see a modest yield increase on soybeans as well. But hopefully we'll get some more data on that crop as well. But it's been really good setup to see kind of what we see for yield.
Sure. And is that pretty consistent with what one would see without, I mean, say you're just looking at irrigated acres versus unirrigated, is that similar yield increase for that? Or is there, benefit of having that tile system in there as well? And
well, that's, part of the challenge is, it'd be nice if we could just say, well, let's look at irrigated areas in Iowa and see what the yield difference is. But, those irrigated areas in Iowa are irrigated for a reason. So they tend to be river bottom soils that are sandy. And so they really need the irrigation. Whereas where we're looking at drainage water recycling is more, what we typically think of as our drained soils. And so, they're a little heavier soils. They're higher water holding capacity, and so irrigation isn't as critical. And that's why there isn't a lot of irrigation in those areas yet. But certainly, we all know that in most summers you hit those few weeks or a month where you go without a lot of rain, and you could really use some water. And so that's the big question then is there enough of those deficit periods where you see a big enough yield boost to justify the investment in the irrigation? And so that's what we're after. So we know we can see that yield benefit. Now the question is, does it pay for itself?
Yep. How often how much can you get that as consistently? And granted, like you said, if you're doing a good job on irrigation, you not turn on your pivot, hey, everything's working out great. You don't have to spend that money to turn it on. But I mean, the way that I'm understanding it is just overall looking at how to optimize those agricultural systems too. Like you said, if they're in poorly drained soils anyway, it's kind of figuring out how much we can get away with there, with also balancing the cost on that.
Yeah, and we can really kind of close the loop a little bit on these systems. And so, again, the water and nutrients that we're draining away, we can capture those and move them back to the field. And so, it gives us the opportunity to really make sure we've got the drainage we need, but then know that we can capture some of that water and put it back at the field at times when we need that water too.
Yeah, and that's what I was going to get to as well, of, start looking at the water supply side versus, in times when you do have that too much water. And that's kind of what some of those other questions that you're looking to answer and to get more information on is, how much environmental benefit are you seeing by slowing down water, hanging on to that water, not letting it go downstream, and also some treatment and stuff in there. And that's where some of the, water quality aspects come into it, where you're not just chasing yield, at the cost of dollars for infrastructure updates, but hey, there's also an environmental benefit here as well.
Yeah, absolutely. And I think that's going to be part of what's going to help pay for these systems. And so, I think most everyone agrees that the irrigation is going to be on the farmer, but creating the storage to do this storage is really expensive once you start excavating to get the kind of storage you need to really justify the system. And so that's where we look at, is there enough of a public benefit on water quality that it makes sense for public investment in the storage part of the system. Mm-hmm. And so, again, that's, we need to work through the economics on if that makes sense, but early results are really promising. And so I think that's, again, I think it's it's really, looks really good right now, but we need the economics to prove that out. But, we're seeing, really strong load reduction numbers on nitrate coming out of these systems, and phosphorus is a little trickier one, but we need a few more years to really tease that one out, but it looks like there's some promise there as well. And so, I think, again, it looks really promising, so you need to continue to work on it to make sure.
Right, yeah. Continue to build that out. And maybe just, maybe there's folks listening that have an interest in some of this. I'm like, hey, that kind of makes sense. Hey, I want to keep chasing after, optimizing the yields in my operation in this way too. Might be difficult because it's going to be different on every acre. But as far as, some of those components with maybe the irrigation system, the tile system, maybe they already have a tile system in, but water storage versus, how much water needs, do you have maybe just ballpark estimates of, how big of a pond does a guy need for 80 acres that he's irrigating?
Yeah. So some of the work that one of our earlier grad students did, he'd done some modeling. It looks like somewhere in that 4 to 6 inches of water for per acre that you want to irrigate. So 6 inches would be half an acre foot. And so for 80 acres, then that would be 40 acre feet that you'd want to have it, or would be ideal to have. So then it depends on how deep you can make the storage. And so again, every system's going to be different because topography sites are different. And so if you can make it deeper, then you don't take up as much surface area with that reservoir. So if you were to go 10 feet deep, then to get that 40 acre feet, you need a 4 acre reservoir.
Mm-hmm.
So once you figure out what you need, you can start to figure out what the math is to make it work out. But yeah.
Gotcha. And then and not to get down too far in another rabbit hole on it, but with the I guess water quality treatment aspect of that too is, from my understanding, wetlands work good when they're saturated, low flat areas. Shallow pools and stuff like that. So that's kind of, you want to maximize the space that you need, or the land that you're using for these storage ponds, but also want to maximize your environmental, your nutrient treatment as much as you can. And that's going to be a little bit of a trade-off in there as well. So that's another reason that it's going to take a little bit to figure out these systems and kind of tweak them in.
Yeah. And I think that really gets into the questions then of who's paying for it and who's paying for what. And so, from the farmer standpoint, they're going to want as small a reservoir as possible because it's going to reduce the cost of that storage. From a public benefit, larger storage is going to have more treatment, and if they can build in some of that wetland treatment, some of that shallow storage, that's going to provide more water quality benefit. So I think as we move forward, it's all going to be kind of trade-offs based on who's paying for what and what they expect out of that. But it's also the opportunity. So I think farmers, again, are going to be incentivized to create as little storage as possible to get the maximum benefit out of that storage. But the public, would probably be, or conservation groups, any of those that might be funding this, ideally they might prefer wetlands because of the benefits that wetlands have. But if they can get these practices out there and farmers are willing to adopt them, then they may be willing to do that because not everyone's going to do a wetland, and there's only so many people that are going to volunteer to do that. And so if this expands the pool of people that are willing to put in these practices for their benefit, but also for the water quality benefits, then hopefully it creates that opportunity to get a lot more of these out there.
Right. Yep. Start proving it out and start seeing that it works, and just need more engineers and dirt workers to kind of get everything designed and built up. But sounds like a fun challenge and a good problem to have.
Yeah. And I think right now the initial sites have all been kind of single farmer landowners doing it on their own site, but I think as we look kind of the future, I think the opportunities can be in these drainage districts or county drainage networks where you've got this shared infrastructure. Some of the work that we're seeing up in Minnesota in some of those drainage districts where you build storage in there, and then you could put that storage to use then with supplemental irrigation. And so then it's the question of how do you figure out the arrangements of who's supplying water, who's withdrawing water, and allocating those benefits. But I think there's, again, real opportunity there to benefit the drainage system as well as the farmers that potentially can use that water, and then the downstream water quantity and water quality benefits that come with that too.
Yeah, absolutely. And that's a message that we've been saying here for a while on this podcast and pretty much anywhere else too that I've had or that come across this conversation of the infrastructure that is in place in many spots is, it's served its life and it's done a very good job. And we're at a point now where we're starting to replace it. But we only have that one opportunity to replace this and do it right. Think about it a little bit differently, and kind of what that looks like is, adding in storage, whether that's storage ponds or adding in treatment, 2-stage ditches in places where they make sense. And then, but still having that benefit in the field of, increased capacity of some of that infrastructure, some of that pipe. But yeah, without having all the downstream effects, and with drainage water recycling and the stuff that you're working on, water's already getting funneled into these big districts, or already coming through here. So the way that we can siphon off some of that, start treating it, and similarly or overall just kind of slow it down in storage ponds and sediment basins and treatment wetlands and stuff like that too. So wanted to make sure that we hit that again of, hey, there's a lot of this that's out there, and that's going to be a big aspect of what we're doing within the industry, how we're doing things a little bit differently, and why we have to think about doing it differently too.
And the time's right, because the opportunity's there as these drainage districts get to where they need to upgrade and perhaps even expand. So
For sure. Well, I got one other random question for you, but before we close out here, and I figured, with your background in irrigation and in drainage now too, with as far as acres in U.S., what's the difference between irrigated acres and drained acres? And if I know there is some overlap with them, but as far as the scale on what's going on in ag on irrigated versus drained.
So the drained areas would be greater. We're about 15% irrigated acres in the U.S., but it produces about 40% of the crop. So that's the real importance of irrigation. But obviously drainage is really critical as well. So those drained acres are some of the most productive acres that we've got. And so I think. One of the things that we're seeing, though, is our traditionally irrigated areas in the semi-arid West. They're declining because of physical and legal scarcity of water. So it's getting drier, so there's less water to begin with, and then you've got more straws dipping into that water supply, and especially as cities and industries expand, they can pay more for that water, and so they're pulling it away from agriculture, and so that's limiting what's available for irrigation. And so as that declines and that production declines as well, then that creates that much more that we need to get off of these drained acres. So, and I think, again, as we look forward, I think that's the opportunity there that the Midwest and these other areas that haven't historically been as irrigated are going to have to pick up some production to make up that slack. And then we look at what's happening with weather too, that we're getting fewer, bigger rains farther apart, and so it's going to make the case for more drainage too, to deal with when we've got these really big events and a lot of excess rain, but then also this intervening periods where it dries up and we don't have enough rain. And so, again, that's the big opportunity with drainage water recycling, so we can really, create some resiliency to both of those. We can deal with the too wet and the too dry, and really create a resilient system.
Yeah, absolutely. And that's the, kind of the main takeaway with a lot of this stuff is, how to optimize what we're doing here. And, with some of those irrigated acres too, I guess I never thought about that too much of that. Some of that's going to be shrinking due to environmental and just water scarcity. A lot of those acres, I'm guessing as well, that those are more or less specialty crops, and not just your traditional corn, soybean like we see a lot around here in the Midwest, right?
Well, yeah, certainly some of them. So, California used to be the largest irrigated state. It's declined enough now that Nebraska has become the leading irrigated state. So, a lot of our the bulk of our vegetable production, especially crop production, is there in California. And so, that's going to start to be looking for new homes as well. And so, but a lot of that irrigation is our typical commodity crops, and then there's a lot of it that's alfalfa too. That perhaps not the highest or best use of water, but they can also produce some really good alfalfa, and there's places that need it, and there's demand for it. But so it's going to affect a number of different crops, but certainly corn and soybeans are going to be some of those too, and it may create some opportunities for some crop diversity in the Midwest that we haven't had for a long time as some of these demands grow.
Yeah, and I think that's kind of the exciting part of that too, as it relates to what we've been talking about with irrigation and drainage infrastructure. It gives you more opportunity to, look at some of that stuff differently, versus you might be more handcuffed if without that, without those tools in your tool belt with, more things with say cover crops or
Yeah.
your other tillage practices or different crops that you're trying out. Is just having more resilient opportunities and infrastructure and being able to handle whatever's going to be coming down the pipe.
Yeah, and we see that already a little bit. That one of our farmers, he grows popcorn and actually seed popcorn, a fair amount of seed popcorn, and so a little higher value crop, and that's how he helps justify it. I know of some others that grow white corn, a little higher value crop, and I think. As we move forward, you might start to see, the seed corn companies start, demanding more and more irrigation to make sure that they're reducing the risk on some of those crops. But I think there's going to be some opportunities in some of these higher value, more specialty crops where you've got that irrigation to give you a little more guarantee on yield.
Right. Yeah, for sure. And that's the last 5 years now. Just the cyclical of nature of what we've been seeing with some of the weather. I remember about when I first started, 2018, 2019 was kind of bad years. Everything was all wet and everybody was all unhappy and too much water and that's causing issues. And then you get into 2020 through last year, dry for pretty much the whole time. I think I was out pheasant hunting in December and we just got a rain. It was the first rain since August. And I think there was only one rain that summer too. So going through some of those swings on too much water, not enough water. And then now here we're in 2024. This spring was a pain as well, especially up here in southern Minnesota. And, it's going to be different across everywhere. But, sometimes people's memories get pretty short on, we were hearing it before. Hey, why do I need tile? Why do I need drainage? It never rains anyway. And then now we get stuck with a spring like we had this last spring. And what I was saying, it's all free advertising out there for where your wet spots are, and you can pick out where your tile lines are, where that's the only thing that was growing in that area too. So, just kind of highlights the importance of having that infrastructure and having the resiliency with dealing with changing weather patterns and climates.
Yeah, among the hydrologists, we talk about the hydro-illogic cycle that, you get too wet and you go into, flooding periods and everyone's worried about, how do we get rid of this water? And we need to boost our flood control infrastructure, and then it dries up and everyone forgets about that. And then, over time, they start worrying about drought and where are we going to get more water? Where are we going to get more water? And so they think about that until it rains again and then they forget again. And so it just seems like you never have the right conditions where you actually get a lot of that infrastructure built because, again, short memories and people forget and move on to the next problem.
Yep, for sure. Well, yeah, and that just kind of highlights the importance of, stuff that we're trying to do here today and talk through some of that stuff. So I guess wrapping up, appreciate you coming on, taking the time out of your day to talk through some of the work that you've been doing, and pretty interesting career with spanning a lot of different areas and a lot of different sectors and states as well. I think we didn't cover kind of everywhere that you went to, but a lot of things dealing with water and with agriculture. And I know you're always a great resource too, to be able to ask some of these questions and have an opinion and some good experience to back up what we're doing and where we're going with it too. So again, appreciate having you on, Chris, and thank you for the time.
Absolutely. Yeah. Thanks for having me.